And I put lots of models live so that I don't get in trouble with the internal press team. So various models across the business we have implemented. So it becomes quite important for us to be able to monitor the models and also to maintain that trust relationship with the business who use the models. So if you're proactive at identifying any issues, the business is very happy about that. On the other hand, if business asks us, what's going on, that's not very good in terms of what our team works on. So, okay, a bit about the presentation, but I already gave a bit of overview. So the main thing is, what do you want to consider, say, when you're setting up the machine learning framework or when you're exploring third-party products? What type of questions do you want to answer? So the classic example is, how does the machine learning project work? So we have our training data. Generally, that's extracted in an offline basis. We perform some experiments, some analysis, and in the end, we build a machine learning model to solve that problem. So even in this stage, you think model monitoring, well, actually, it can be applied to the training data to better understand how does your data change over time, or is there any change? And that context is really useful when you go into live deployment, because if something changes, now you have a bit of a baseline. You have context on why something have changed. Is it seasonality or not, for example? And then what happens in the next stage? Well, we deploy our models. So pretty much similar, but what we do is we productionize our code. Right? So we have a machine learning model. We put that into an API. We host that somewhere. And then the business system will call our API to return a decision. So pretty standard, right? But where can the model monitoring occur? Well, the first thing is, in the deployment, we need to make sure that the data needs to be same as the training data. And that's not always the case, but that's where you need the monitoring. The next is inside the API, right? We are changing the data maybe some ways. Is there any unexpected behaviors? We really need to be able to identify that and to alert it when it's needed. And then finally, we're returning the decision back to the business. So we probably want to monitor the predictions, right? But the issue is that, what is a machine learning model? We designed it so that it rarely fails, right? So think about it, because it's in a production environment, right? If we have, I don't know, things that are, say, missing data coming in, we probably need a way to handle that. So the model will keep generating the predictions, and it can fail really silently. So without really properly monitoring what's going on, things might be too late, right? Business might notice things that turns out maybe something to do with the pipeline. Maybe, I don't know, third-party data is not coming in, so that the whole predictions change a bit. So there's a couple areas I think it's quite important to monitor the data. So that brings us to, what should we do when we consider designing a monitoring framework? So I quite like the paper here by Google, so in the hidden technical debt in machine learning. So here they say that changes in the external world may influence system behavior in unintended ways. Even monitoring ML system behavior may prove difficult without careful design. So, something that is very generic, right? That could work. In theory, it could work. It sounds good, but does that really work for your business? Or what are you trying to identify, and can you implement that? And similarly, how important is the machine learning code, right? So here's in the same paper, we had a diagram where we have the black box. That's where the machine learning code is. A small proportion of the successfulness of the project. So how can it be successful? It really depends on all the other areas. And luckily, they put a monitoring one in there, because or else I don't really know what to talk about. And so now going into a bit about what type of monitoring. So when talking to business, right, people say, right, let's monitor things. What do they mean? Well, they can be three things. So we have if you talk to the IT system, they might be interested in the infrastructure, so CPU usage, maybe memory usage, response time. Those are quite important. but that is really not the data science team's monitoring abilities. And then on the other hand, we have the business, we have the KPIs. Again, very important for the business, but right, how does our model influence that KPI? If the KPI changes, does that mean our model have changed? Right? Or also, the business can come back to us, oh, our KPI have changed, what's going on? So we need to really understand how it changed from a modeling perspective, and that's somewhere in the middle. So given a couple of scenarios, again, about right, when people think about how do you monitor data, so there can be various approaches. Some is appropriate, some is easy to implement, maybe not always. So the first is a change in the target. So this is quite an important one, and maybe one of the things that comes in at relatively early on is have our model degraded over time. Well, if it degrades, maybe we can take action, retrain the model, but in our case, it can not be that feasible. So, for example, if you have a website that predicts, I don't know, customer dropout, right? You can get the target relatively easily, also in relatively short period of time. So then you can feed that, you can measure that. But for insurance, our feedback loop is generally very long. So think about a policy, right? It might take a year for somebody to make a claim, and then can we really wait for a year to say, oh, by the way, something happened wrong 9 months ago? That's not going to, I don't think I can keep my job for that. So that part becomes very useful, but not so easy to measure. So then the next part is, well, then we can measure our predictions, check out, have that change over time. But when we deploy a model, that model is, so changing the prediction doesn't really mean that the model have changed in any way. We are not really doing online learning. So how can the model change then? Well, there's the next couple of ways that the models can change. So one is a change in the input, and this is what's called covariate shift. So this is something that now become feasible to monitor. So this is, what does the model sees, or what is the input data coming in? For this, I would say, giving a couple of examples, for example, last couple of weeks we have a lot of storms, right? We might see a change in the input. We have a lot more roof damage to home insurance. So that could be a change in the input. But that is a one-off thing. So it's important to understand, again, we want to monitor change, but what actions can we take? So if it's a one-off thing, maybe that we don't need to update our models. We need to understand the impact, how that changes. But on the other hand, we could have a change in the behavior. So again, just to give a very generic example that's not specific to LV. So think about, say, for example, fraud, right? Before COVID, maybe there's a lot of cars on the road. Fraudulent behaviors could have certain features. Once COVID hit, less cars on the road, the fraudsters can't really carry out their activities, so maybe they change their behavior. So they could change the decision boundaries that the model have been trained on, and that could impact the model, and also the performance of the model. But that one is a bit harder to identify, say, compared to the change in the input. So that's something called concept shift. So some of the easy wins that you can achieve when doing model monitoring is, well, actually first you can check for some data qualities. So here, actually, as LV, we have open sourced a package called Input Checker that does exactly this. So feel free to go to our GitHub page to check it out. So easy wins, right? Check the missing values, check the types, check, if you have a numerical value, what is the expected range. And generally, that can capture a lot of things that goes wrong with a model. So then, well, okay, so that can sit relatively early on in terms of API, where we receive the messages coming from the business. And here's another type of, here's another graph that I find really useful to convey the message of monitoring. So it came from the paper Learning Under Concept Drift, a review. So again, when we talk about monitoring, people might have ideas about how it is. Generally, they think it's quite easy, but I don't think that's the case because I'll give a few examples of here what that means. So first is you can have things that changes incrementally over time, right? Something changes slowly, like say the repair cost of the car. The car gets more technology in it, and over time it's more and more expensive to repair the car. So that changes very slowly. We can have something that is reoccurring, so something seasonal maybe, right? In the winter time you have more freezing pipes. Escape of water claims very expensive, so maybe something that's reoccurring. And then we have the sudden drift. That's relatively easy to detect, and probably something that when people think about want to monitor things, that's like, oh yeah, I want to measure something changes, probably something like that. But the thing is, in our live production environment, we don't really know how the data can change. So when we design a system, we really need to think, right, can it capture one? Can it capture another type of change? Does one type of method is suitable for another? So for example, say if you want to compare today's data versus yesterday's data, then a sudden drift, yeah, probably you can detect that, but then you probably wouldn't be able to detect incremental drift unless you increase the sensitivity. But then, well, you have a lot of false alarms. So yeah, it becomes quite difficult. Plus the extra added noise in our data set means sometimes it can be like a gradual drift instead of sudden drift. So when you think about, all right, here's a machine learning framework that we want to monitor data, just keep in mind, right, there's various ways that the data can change. Maybe it's suitable for one, but not really suitable for another. So maybe you want something that's more generic to be able to capture all of them, but it might take longer to detect, or you can go for something really specific. So I think a lot of monitoring solutions, they monitor things like metrics, right? They monitor, say, the mean over time. And that is quite good, right? It's relatively easy to calculate. It's well, yeah, you don't really need, the volume is really not a problem. But here's an example of a couple of distributions. It's a famous example. I'm not sure how to pronounce it, but where you see the mean is exactly the same, but you have really entirely different distributions. So then the question is, right, do you want to measure the mean? Is the change, is that what you want to capture? Is that captured in the mean, or is that something that is, say, an outlier that might not be reflected in the mean? Bear in mind, we can have outliers. We also have noisy data, so sometimes it's a bit hard to identify the one from another. So then what we can do if we don't want to, measure some sort of metrics, then we can compare, say, two distributions. Right? And in this case, there's a lot of statistical tests that does that. But again, here, what you want to keep in mind is this multiple comparison problem. So statistical tests have a p-value, which means occasionally the distribution is the same, but it would have a low p-value. So when we have a lot of models in place, you think, when each model have a lot of features, it's very easy to end up monitoring hundreds of features. So then we have a lot of false alerts that's coming into the model, and it's again harder to distinguish what is a real change versus some false alerts. And again, you don't want people to constantly investigate false alerts, and then what's that story about the sheep and the wolf, I think, where they keep yelling anyways. So yeah, so that could be an approach, right? It could be suitable. Another approach is to calculate some sort of metrics to quantify the distance between the two distributions. And this, again, is quite useful because now you can look at things over time. You know, the higher the number, for example, the more different the two distributions are. And that helps maybe add a layer of logic on top of the statistical test so that you can better understand how your data changed over time. So then, generally, then we want to compare is two distributions and generate some sort of result, right? So, and again here, this again another small point, but I think quite a crucial point is that something is not really, say, advertised as much is how do you choose that two distributions, right? You could have when you choose that distribution, sometimes a lot of the frameworks or the packages, they just say, all right, give the two distributions, we can generate some sort of monitoring. But as you can see, just a hypothetical example here, right? We can have we have changes in the distribution, but if we aggregate things, that might not be captured. So here, I think what's important is, again, going back to the training data. So do you understand how your data changes over time, right? Can you provide that context so that when you want to monitor things in a live environment, well, then you have maybe more information at your disposal to be able to choose that. So with the noisy data, if you have a too small time window, then again, it can trigger a lot of false alert. If you have a very large time window, you might not capture things that happen on the shorter time intervals. So experiment with, say, the time duration. I mean, this monitoring framework is, it's also a feedback loop as well, right? So you need to understand how things are, and then incorporate that back into your monitoring solution. Similarly for categorical stuff, yeah, just as an example, right? So then the next part, okay, so we have done our offline monitoring, maybe you look at training data, we package it up, we can produce some results. So the next part is, well, similarly to productionizing the models, we really need to productionize our monitoring solution. And here I would say it get involved with the data engineers or the people who will implement it as well. So as data scientists, we might be able to help or contribute with a technique of how things work. But in order to implement it, there's a lot more consideration that needs taking place. Going back to that example where we have the small box as a machine learning model, a lot of other components needs to fit in. So what to think about here? One thing is the logic. So something that works well in an offline setting might not be really feasible for the online setting, right? In your local VM, you can really handle data of any sizes, but how do you retrieve that in a live environment? So how do you get the logs? How do you combine the logs together, right? How do you process those things? In terms of volume, another critical issue to consider. So, if the API call gets, say, like 1,000 calls a day, okay, relatively easy to get the data set, right? If we have models that are called, say, 1 million times or 10 million times a day, then it's not very easy to say, oh yeah, I just need last years of data and then I can monitor it, and then time is not a problem in our monitoring solution here, memory is not a problem. Well, that's not really the case. So something that maybe could be use case specific, right? You could use it for one type of use case, might not be suitable for another type of use case. And then suppose now we have a monitoring framework in place, right? We deploy that, we are monitoring things on a daily basis, we're generating results. And then usually the business could ask is, well, what actions can we take next, right? If something changes, what can we do? So here, I would say, well, first, again, data scientist is, I wouldn't say we are subject matter experts, right? So you really need to engage with the business to understand, right? How did the data change? You know, is that something that we expect, or is that something that say is out of the ordinary? So again, going back to the example, say if we have now more roof damage claims coming in, when I look at the result, I'll be like, oh, right, something is wrong here, right? Maybe I need to change the model. But then from the other side, from the business, it would be like, oh yeah, there's like some storm going in. We expect something to change. So does it impact the model's performance? No, we need to investigate that. So no fast trigger fingers to retrain the model. Just understand the impact first, and then decide to retrain. Or maybe you can find other ways to deal with a model. So maybe some manual adjustment is needed, right? Maybe, for example, for fraud, a certain segment, you're not very good at predicting fraudulent behaviors. Perhaps you can increase the threshold so that you have better accuracy at identifying fraud, better precision. And then incorporate that learning back. So as we develop our monitoring framework, you know, the first iteration, we got something, and then we learn from it, and then we can then think about, okay, how can we improve it, right? What information, additional information, can we provide so that we can better explain what the monitoring output is? So again, here you see, a lot of times you can't treat the monitoring as a black box, because if you say to the business, all right, something have drifted 50%, and then they come back with, so what? And you're like, we don't really know why that numbers gets calculated. Again, I don't think then we can keep our jobs. So we really need to be able to understand what's going on underneath, and then we can take actions to either change our models or to have some manual adjustment. Yeah, I think also just to highlight some of the benefits of having a machine learning framework. So one is you're better at monitoring your model performance. This trust with the business, that can improve a lot. You know, business is going to be very happy if you say, oh yeah, something that we noticed here, right? What's going on? Yeah, they'll be very happy about that. Also saves a bit of time, right, to do ad hoc related stuff, right? We have a package framework in place, then we can focus our time on other projects. And then in terms of retraining, again, this can help, right? Going back to the target, we might not be able to always get the target, but if we can understand how our model or how our data have drifted, then that could prioritize what model we can train and which one we leave out. So with that, I think, I don't know how much time I have, but
perfect.
Yeah,
5 minutes for questions. So thank you, Dapeng.
Yeah.